When we're talking about circles, there's kind of a standard equation that we use for circles. And that standard equation looks like x minus some number. I'm just going to throw a number in there right now. And then y minus some number is equal to something squared. And I'm going to call that, let's make that a 4 over there right now. So if I handed you this equation for a circle, and I asked you to sketch it, or I asked you to find the radius, or I asked you to find the center, all three of these should come pretty quickly from looking at the equation. So I'm going to start at the bottom up and say, when we're looking for the center is going to be whatever coordinate makes these two pieces go to 0. So what value do I have to plug in for x to make x minus 3 equal to 0? I've got to plug in 3. And the value of y that I need to make y minus 1 go to 0 is going to be 1. So that tells me that the center of my circle is at the coordinate 3, 1. The next piece of this for finding the radius, if it's in this standard form already, where we've got these two perfect squares and a number hanging out on the right-hand side, then this number is equal to the radius squared, which tells me my radius is going to be 2. Just a cautionary note on this. In general, if I'm solving the equation r squared is equal to 4, this actually has two solutions, because there are two values that I can plug in for r to make this equal to 4. This has a solution of r equals 2 and a solution of r equals -2. The issue is that there's context to this problem. We're looking for a radius, and I can't draw a circle with a negative radius. So we're going to ignore the -2 portion in answering the question about the radius. So if I had this, I could now, armed with all of that, sketch a quick graph. And it doesn't have to be perfect, right? It's a sketch, but I should be able to draw something along the lines of over 3 up 1. And then if it's going to have a radius of 2, one of the things that's important in terms of sketching things in the 16 series, it's not super important that you're like doing this on graph paper and you have your fractions perfectly lined up, or that you've got those little tick marks perfectly spaced. But it is important to note that because this circle is shifted up 1 in the y direction, but the radius is 2, I know that it's going to dip down here below the axis. And because it's shifted out 3, but the radius is only 2, it's not going to extend past the y-axis. So there's my sketch, 3, 1 with a radius of 2. I know it's a circle because I'm looking at an x squared and a y squared, and someone has given us a hint in terms of how to get started here, and that is that we're going to regroup our x's together and our y's together. So if I group our x's so that I've got x squared plus 6x, and I group my y's so I've got the y squared and minus 4y. And I'm just leaving myself some space here and pushing that 5 off to the side. Sometimes people are really good at completing the square and can just see all of this in their head. You all have already taken an algebra or a pre-calc class, so I'm gonna like push the fast forward button. At this point in the game, we just have to kind of be able to do it. And if someone wants to come to office hours, I'm happy to walk through why this works. But the bottom line is we got to know how to do it. So if I'm going to complete the square, That means that I'm trying to write this in a form that looks like x plus or minus something squared. So I'm looking for this to be a perfect square. And in order to get there, I know that what goes inside here is half of the coefficient on that x. So if this is a plus 6 and I take half of that, that means this is going to be plus 3. But if I were to actually multiply this out and like FOIL out that multiplication, I would end up with x squared plus 3x plus 3x plus 9. So I'd have that 6x, but this 9 wasn't there in the original problem. So when we complete the square, the way we fix that is I'm going to add the 9 on and then subtract it right back off. So the part where I added it on, that's what's going into my perfect square piece. And that minus 9 we'll deal with in a minute. If I come over to my y's and I do the same thing, and I say, okay, well, I need this to turn into a perfect square, then I'm going to have y, and if I take half of -4, I'll end up with -2 squared. But if I multiplied that out, I'd have y squared minus 2y minus 2y plus 4. And that plus 4 I need, so I'm going to invent it for myself. I'm going to add the 4 in and then subtract it right back off. So to get to our standard form, this middle line here, I've got that x plus 3 squared, got this plus right here, but I'm going to take that minus 9, I'm going to add 9 to both sides so that I end up with a plus 9 over here. And I'm going to add 4 to both sides so that I end up with a plus 4 over here. So I'd end up with 5 plus 4 plus 9. Now this line down here, I wouldn't actually write. This was kind of just me doing my scratch work. So I'm going to go ahead and erase it. And clean up this right-hand side. So 5 plus 4 plus 9, what's that, 18? So I've got 18. I've got y minus 2 squared and x plus 3 squared. So now if I was asked for the center and the radius, the center is coming from whatever makes each of these equal to 0. So I would need to plug in -3 to make that go to 0. So my center would be at -3, and then my y value would need to be 2. And the radius would equal the square root of 18. Suppose that -1, 3, and 9, 11 are diameter endpoints of a circle, and I want to write the equation of the circle. So for any circle, there's 2 things that I need to know. Because that standard form for a circle is going to look like x minus h squared plus y minus k squared is equal to r squared. So I need to know where the center is, and I need to know what the radius is. So we can do this with a graph or without a graph. I'm kind of a visual person myself, so I'm going to at least kind of get a fake sketchy graph going here. So I know that one endpoint is at -1, 3. And the other endpoint is at 9, 11. So I don't know, somewhere out here, we're just going to call that 9, 11. And if those are diameter endpoints of the circle, then my circle kind of looks like this. Which makes my center somewhere in here. So if I were to draw a line between -1, 3 and 9, 11, the center of my circle would be right there. I am going to give everybody 30 seconds to see if you can come up with what the center of our circle is. So that center is going to be in the middle of these 2 points. So I know that the x coordinate for our center is going to be the average of the 2 x values at the points. How do we find an average? We add them and divide by 2. So the center is going to be at -1 plus 9 divided by 2, the average of my 2 x values. And then I need the average of our 2 y values. So 3 plus 11 divided by 2. So if I simplify that, what's that? 8 over 2, 4, and 14 over 2, 7. So that's the center of my circle, is at 4, 7. So I can already get that plugged into our formula. There are 2 ways to do this next part. So one option is to use the distance formula to find the radius. And the other option that I think is easier, it's exactly the same work. But if this is the equation of our circle, that means this equation has to work for every single point on our circle. And we already know 2 points that live on our circle, which means if we plug in one of those 2 points for the x and y value, we're already going to know what the radius squared is. And that's the way that I'm going to approach this. So that point 9, 11, if I go ahead and plug that into our circle, then that's going to look like 9 minus 4 squared plus 11 minus 7 squared is equal to r squared. So I've got 5 squared, that's 25. 11 minus 7 is 4. 4 squared is 16. 25 and 16, I think it's 41. So my r squared value here is 41. I'm going to be careful to erase that word radius there, because my r squared value is 41, which actually means that the radius would be the square root of 41. And if you did the distance formula, right, so this was just one approach. I think it's the fastest approach to just plug one of your 2 endpoints in. But if we had used the distance formula, I do briefly want to talk through that, because we know that the center point was 4, 7. So one thing to be careful about when you're using the distance formula, we're looking for the radius, not the diameter. So when you do use the distance formula, I recommend going from finding the distance between the center and one of these 2 points.